please join me on page 20 of your science book. This is chapter 1, lesson, I think 3? Yeah, 3. So this is page 20 of your science book.
Yep, I see it. I totally
Now, we have been talking about light energy and how light can refract, which means it bends. Light can reflect, which means it bounces back, or light can be absorbed. We also looked at how the human eyeball works to take in light and change those change that light energy into images in our brain. Now we're going to be talking about sound and how sound energy works. So, sound energy, the blare of an alarm clock, the beep of a car horn, the quack of a duck, and the rumble of thunder during a storm are all sounds. Sound is energy in the form of vibrations passing through matter. A vibration is a quick back and forth movement. So, sound is energy in the form of vibrations passing through matter. So a vibration is that quick back and forth movement. And sound occurs when objects vibrate. So if you have your phone or whatever on vibrate and it goes off, you can hear it if you have it set on a table. You know, you hear zzz.
Yeah, I have a lot.
So, you know. Sound travels through solids, liquids, and gases. Sound cannot travel through empty space where there is no matter. So, I'm going to highlight that because that's important. Sound cannot travel through empty space where there's no matter.
Like inside something where, like, there's solid. It's not hollow, right? What? What?
Bobo. So, like in outer space or on a different planet where there's no air, sound cannot travel effectively.
Well, science fact about sound. Did you know that space protects us from the sound of sun? Yeah, because actually, if space did it, the sound of the sun would be too loud for our eardrums. So
That's right.
I think so. Yep.
That's right. If the sound of the sun, was able to travel and reach us, it would be deafening.
Yeah. And also it could it would end everything. There's more. I just said that.
Yes.
It would be.
I'd overheard y'all, and I was
It could
confirming that that's true.
It would destroy your hearing of sound.
Mhm.
It would end everything.
All right.
It would end everything. It would end your hearing. So it would end everything.
Pluck a guitar string, and the string starts to vibrate. The vibrating string passes energy to the air around it. The sound energy travels outward as sound waves. A sound wave is a disturbance that moves sound energy through matter. When the waves reach your ears, the waves make your eardrum vibrate, and you hear the sounds made by the guitar string. So, you know how like our eyeballs take in light to be able to see? Your ears take in sound. So your ears have something in there called an eardrum, and your eardrum picks up the vibrations in the air, and anytime there's a vibration in the air, your eardrums vibrate.
But whenever the eardrums are
I know a lot about
damaged,
eardrums
they don't
because I have an eardrum problem. It has a horn.
I just want to say that if your eardrums are damaged in any way, they won't like bounce off the sounds, and then I'm pretty sure we couldn't hear.
You're right, you can't hear as well. And then if it's severely damaged, I'm assuming that would probably cause deafness.
So the eardrums are not the only thing that helps us hear sound.
Correct.
So the ear is mostly made out of cartilage.
Yep.
But the ear also has tiny little bones, so when they hear sound, they vibrate, and
Yep.
that's what makes us hear sound.
Yep. And
There's
also,
bones in our earlobes.
yes, not in your earlobe, but way down in there past your eardrum. There are bones.
Oh, okay.
And then also, your ear canal is filled with thousands of tiny little hairs. And those little tiny hairs vibrate as well. And they amplify the vibrations.
Oh, so they amplify the vibration, so we can start to hear them.
Yep. Yep. And then if you listen to, like, if you put your headphones in and you listen to music that's really too loud, or if you're around a lot of loud equipment all the time, or if you like my husband, he's a mechanic, and so it's constantly loud where he works. But that can damage your hearing, because what it will do is that those little baby hairs, it'll eventually start to make those hairs where they won't vibrate correctly. They all kind of lay down after a while.
Sound pollution. Also,
Sound
I
pollution.
have pollution.
Everyone has sound. Wait, really?
If you didn't have like headphones.
Yes. Yes. All right. So let's talk about how sound travels. Ooh. So my camera's wiggly a little bit. All right, here we go. As sound waves move through matter, they set particles in motion. The moving particles form a pattern. Areas with groups of particles that are bunched, sorry, I lost my place. Areas with groups of particles that are bunched together alternate with areas of particles that are farther apart. The areas where particles bunch together are called compressions. Sound waves travel at different speeds through matter. Sound waves travel quickly through most solids and liquids. Sound waves tend to travel more slowly in gases. So, they travel in different speeds through different matter. They go quickly through solids and liquids and slowly in gases.
So it's more.
Mm-hmm.
So sound pollution is like really bad for your hearing, and if you hear if you constantly do loud noises, can it also affect your eardrums?
Yes.
How?
It can actually, if you expose your ears to loud sounds repeatedly, too much, it can actually burst your eardrum. Like if one really loud sound can rupture your eardrum.
Oh yeah, it just like walls, you just keep hammering and hammering, and it just keeps cracking until finally
It busts.
Yeah, it's blow then.
Yep. And also, if you have a bad ear infection, you can rupture your eardrums with bad ear infections too. Grant?
hole in both my eyes.
Grant's talking.
I have noise pollution, and whenever I get frustrated or worried, it starts to hurt.
So you have some noise sensitivity. I do too. Like when we have fire alarms and stuff, I always have to cover my ears because I don't do well with those kind of sounds.
Okay, you know how
Wait.
it's just anything that's inside our body. I say it's more. And my brother's friend, he tells me a heart. It's more. I'm gonna say real quick. Yeah, you know when things are a board and they scrape it. I hear scrapes like little scrapes with your fingers, and whenever I hear that, it sends a vibration down my body. It's like a little chill.
Yes. Owen.
I have a hole in both of my eardrums, I think, and it kind of makes it hard to hear sometimes, and sometimes out of the blue, it's just like, why is there no for now?
All right. So let's continue talking about frequency and wavelengths. Waves can travel in different ways. They can carry different types and amounts of energy, but all waves have certain properties. Frequency and wavelength are two of these properties. The frequency of a wave is the number of waves that pass a point in a certain amount of time. Frequency is often described as the number of complete cycles a wave makes in 1 second. A cycle is one vibration. Wavelength is the distance between a point on one wave and a similar point on the next. Studying sound. One way scientists study sound is by using oscilloscopes. That's a mouthful.
Wait, oscilloscopes is that little like greenish light waves
I am not sure.
that make light waves.
You know what those blue, you know, the things that make sound? You know what that reminds me of?
What's that?
Did you know we have never touched anything?
I know. Isn't that weird?
Yeah, because
There's always particles of atoms of air between
we never
you.
touched. So I'm not touching
We
it.
never touched anything.
It's weird. It's mind-blowing. Mind-blowing. Mind-blowing.
Wait, what?
We never touch anything.
All right. We gotta stay. Let's focus on sound. Okay. Focus on sound. All right. Here we go. I know, all this is so fascinating. Okay. Yes, I do. Question mark. An oscilloscope is a device that takes a sound wave and displays the shape of a wave on the screen. So like this is the, this would be like a printout from the oscilloscope.
What is that?
So it says, look at the oscilloscope screen below. All right, The signals are displayed on screen in the form of a wave. Compressions in a sound wave show up on a screen as crests or high points. So these would be like the compression points. And the troughs are also part of the compression points. The wavelength is going to measure the distance between two waves. A frequency is going to tell how many waves came through during the cycle. Okay? Now let's talk about pitch. Okay. People experience the frequency of sound as its pitch. Pitch is how high or low a sound is. Pitch depends on the frequency of the sound wave. Objects that vibrate more quickly have higher frequencies and a higher pitch. Objects that vibrate more slowly have lower frequency and a lower pitch. The notes you might play on an instrument are measures of the pitch of the music. So, you know how usually women who sing have a higher singing voice and men who sing, their voices are usually lower. So, when a woman sings, her voice box is vibrating faster than a man who is singing. His voice box vibrates slower because his voice is lower. So the higher a sound, the faster it's vibrating. The lower the sound, the slower it's vibrating. Right, but I'm just saying, normally. So count it in. 3, 2, 1. Colton with the C. All right, so. Oh, okay.
So, you know where I learned that from?
Tell me.
I learned it from a meme, because the meme was, so I'll put it over that, and they didn't say that, they said, so the man said that punched him, said, no sir, I did not punch this man because atoms don't touch each other with atoms have never touched with, I forgot what that was.
Gotcha.
So, no, I did not punch this man.
Don't work like that, unfortunately.
Miss,
So,
technically.
I tell you what, we'll talk about that, but let's finish up with sound first, okay? We'll talk, but let me finish this first. Okay, so, the material of the object making the sound and its size and shape also affect the pitch you hear. A tuba, for example, is a musical instrument made of many feet of brass tubing. Tubas make low-pitched sounds. So the bigger an instrument, usually, the lower the sound. The smaller an instrument, usually the higher the sound. That's why a flute or a piccolo are very high-pitched instruments versus a tuba, which is super low-pitched. No, not a pickle. A piccolo. A piccolo is like a mini flute. It's like a really short flute. Not a pickle. Yeah, because a whistle is really small, so it makes a really high-pitched sound. Charlie.
You're telling me Ed Sheeran sings low pitch?
Lower than some people.
You telling me Ed Sheeran sings low pitch?
Lower than some people. Okay, we got it. Y'all, we're so close to being done. Look.
We're so close, guys. More. How cartoons are.
That only works
Now,
for you.
Charles, play the piccolo. Okay, play the piccolo.
That would be it. Yeah, I can see it. All right. This is kind of cool too. Some sounds are too low pitched or too high pitched for humans to hear. Have you ever seen that thing where somebody like uses a dog whistle and like we can't hear anything,
Yeah,
but the dogs come running? That's because it's too high pitched for human ears to pick up. So we cannot hear every sound. There are some that are outside of our ability to hear.
I know, it's like that. So it's like low density or like kind of high density things we can hear, but
Vibration, pitch and vibration.
Once I saw a video.
It's the pitch and vibration, not density. Density is something a little different. It's a good science word, but doesn't quite fit here.
Some people's voice is so high or so low that it can like glass.
Right? Yep. Cool.
they do. So you're
keep going, you're going, you're telling me what I'm doing.
Oh wait, I can do it too. Crap. What? I'm confused at first. Like, how do you put your keep this finger still? But.
Okay, let's move on now. All right, volume. So, when we describe a sound, we often mention its loudness or its volume. Some sounds are louder than others. A jet engine makes much more noise than a car. What is volume? Volume is a measure of how strong a sound seems to us. The more energy there is in a sound wave, the louder the sound and the higher the volume. So when something is loud, it has more energy behind it. Just like when you yell, you know, if you were to shout, that takes more energy than whispering. The volume of a sound is related to its amplitude. Amplitude is the height of a wave measured from its midline. The higher the amplitude of a wave, the more energy it has and the louder it sounds. Suppose you turn down the volume on the TV as soft as it'll go. You can barely hear it. Then you turn it up as high as it'll go. Now you have to hold your ears so they don't hurt. You have not changed the pitch of the sound. It's not higher or lower, but you have changed the volume because you've changed the amplitude of its waves. Let's look back at this oscilloscope thingy-mabobber right here. So, amplitude is measured from the midline to the top of the wave. So like this would be the amplitude. The higher that is, the louder it is. You said that's not true? How's that not true? What you talking about?
Nothing. It's not important.
Oh,
There's more.
I was about to say, if you see something different.
Your TV at 4% volume.
Oh, okay.
There's more.
Gotcha. I thought you were talking about this, and I was like, Charlie, it is true.
I can hear it from
There's
one.
more.
So again, if we were to measure, from the midline up to the very top, highest point of the wave, crest, that would give us the amplitude. The higher that goes, the louder it is. Okay? So, tomorrow we are going to continue talking about the different information surrounding sound and sound energy.
You just